Hi everyone, this is the last video of the week. It's only Wednesday, but I'm not going to see you again like this until week 6, and it's America's birthday on Saturday, so happy 4th of July. Okay, now this lab, I'm going to make it due on Sunday, so you can, have a hot dog or two without stressing out, right? So as long as it's due, before Monday, by the end of Sunday, that's fine. Okay, now it's a pretty straightforward lab if you follow the golden rule, which is watch the gases video and complete that gas packet first. So all the kind of intellectual information you need is in that gases video and packet, right? So once you've successfully completed that, and I think I set deadline for that for Friday, right? Okay, then and only then try this. Okay, now the experiment itself, obviously it's not an experiment we can do because we're at home, but it's a very, very simple experiment. It's the pressure-temperature relationship, right? That's Charles's law. So if you want to review that particular page in the gases packet, that'll really help, okay? And we have a fixed volume container, so it's temperature versus pressure, okay? And we're basically submerging a container, a fixed volume, a glass container, in a water bath, okay? And we can measure the temperature of the water bath, therefore that's the temperature of the gas also after it's come to equilibrium, okay? So we can change the temperature of the water bath, change the temperature of the gas, and then this little hose here goes off to a pressure gauge, right? We can measure the pressure. So our variables will be pressure and temperature, right? And on the next couple of pages we'll see their graph, okay? Or we'll see their data set, okay? All right, so it's a pretty simple experiment. Measure pressure, measure temperature. What do you expect to happen? Well, if you've seen the video, of course, as temperature goes up, the speed of the molecules increases, so they hit the walls with more force, the pressure should go up. Okay, so it's a proportional relationship. I think I just didn't give anything away, but that's one of the questions, right? Okay, so there it is. Okay, so there it is. Now, careful as you fill this out. Don't try and do too much all at once, right? So, very simple. There's the data set. So they record the pressure at a certain temperature. Now obviously, you've looked at the packet, PV equals nRT, fair enough, but T has to be in Kelvin, right? Okay, so here we're going to first of all convert all these to Kelvin. I'll do the first one for you. 273 minus 6, that's easy, right? 267. Now you'll have a different data set, different values, okay? But fill these out, just convert Celsius to Kelvin by adding 273. Okay, fair enough, nice and easy. Don't do anything over here yet. Okay, that actually relates to question 5, which we'll get to in a moment. Okay, now let's talk you through again. If the gases video is fresh in your mind, this will be common sense, right? So in order to perform this experiment, which two factors were kept constant? Well, you're measuring pressure and temperature. In PV equals nRT, what are the other variables? There's two of them, of course, right? Those are the ones that are kept constant. Based on the data obtained for this experiment, in words, and feel free, this is a document, right? So, feel free to kind of insert your cursor here and hit return a few times. Make more space for yourself. You don't have to fill it all in this tiny gap. If you need more space, use more space, right? Okay, but in words, just express the relationship, right? What's the relationship between these two variables here, okay? Based on the data, express in words the relationship between pressure and temperature. Do they rise proportionally, or are they an inverse relationship? That's my question, all right? And then, go back to the video, we talked about it on the very first page of the video, how pressure is kind of understood on a microscopic level, okay? So again, watch the video and expand that section as well, right? So if you want more room, obviously that's too small, it's a document, just make more space. All right, now here's where it gets interesting. If you saw my derivation of the ideal gas law, this will be somewhat simple, right? But we're not using R, right? So we're using K, right? Okay, now if they're directly proportional, so 2 is proportional to 1 as 4 is proportional to 2, right? Those are proportionalities, but how do I make proportionalities equal? I put in a constant, right? So 2 equals a constant times 1. 4 equals a constant times 2. The constant's actually 2, isn't it, right? So K is your constant. You can write a relationship and throw the constant in. So it might be pressure equals, well, I'm not going to tell you the answer, right? You can write your own relationship in symbols, right? Okay, in symbols. Okay. Look back to that derivation of R, and it's a simpler version of that. Okay, now, here's the thing. Here's some details, right? You have to determine, and we've kind of already told you the answer, right? You have to determine if pressure and temperature are a proportional relationship or if they're an inverse relationship. Okay, so if you looked at, for example, Charles's law, we double temperature, we double pressure, they rise and fall together. So if we divide the two numbers, they're always the same number. Hint, hint, right? But if we have an inverse relationship, and look how we looked at the Boyle's law, right? If they go in opposite directions at the same speed, that's inverse. And think about what we did there. Okay, so just check back, and it was P times V was a constant, right? So it should be kind of just a couple of seconds thinking about it, which one of these is right for a proportional, okay? And then, I think I'm pointing to the right one. Then just use that relationship and work out K over here in the first page, okay? So then you've got your K, yeah? So then you have a relationship between pressure and temperature that's an equality, that equals, right? Because K will make it equal, all right? And then, hey, once you've got your equation, you can go on. It says use your graph. There is no graph. You have an equation you've just made, right? Okay, and the equation you've made should work for every pair of data sets, all right? So if you like, the small number times the constant is the big number, and we're using Kelvin and temperature, right? Okay. Think about the order of things in PV equals nRT. Okay, P is proportional to T, and I can't get any more hinty than that. Is hinty a verb? Okay, I think I'm feeling the 4th of July coming to me. Right? So, yeah, as a oh man, I was going to say recent American citizen, but I've been a citizen for like 10 years or something, which is kind of cool. More than that, actually. Okay. Actually, if I remember, I'll throw up a picture of me at the graduation ceremony for the citizenship, which is kind of cool. Okay. I actually became a citizen when President Obama was in office. I have a letter, not signed by President Obama, but auto signed by President Obama. Okay. Okay, so that's kind of cool. Anyway, back to it. Enough of that stuff, right? So you have your equation. It should fit this data. Now, this is experimental data, so I expect a little bit of fudge. It may not perfectly match, but hey, you've got the relationship, you've got the equation, and then you can use your equation to solve this last question. Okay, hope that all makes sense. Now, as usual, all right, I'm a bit disappointed because no one's talking in discussion. If you have a question about this, raise it in the discussion for this experiment or in the water cooler chat. I did see a question in the water cooler chat which one of you answered. That person, you know who you are, you got a point of extra credit. And kudos to the person that asked the question, because the question was answered correctly, and I hope that helped you with your lab. Okay, so discussion between students is highly encouraged. Okay, highly encouraged. As I mentioned in the previous video, personal communication with me doesn't really help anybody, okay, because lots of students in the class typically have the same question. So if you ask the question in public and it gets answered in public, that helps everyone, okay? So I'm not being rude when I say ask this in water cooler or something. I'm just trying to help more people. Hope that makes sense. Okay, I'm going to go to Indiana and buy some fireworks. See you next time.